Okay, I'll hit the timer now. Let's get started. Time is hit. So, this is question 1 of P4 January 2025. The curve shown in figure 1 has equation that the region R bounded by the curve, the y-axis, x-axis, the line with equation x equals 8. So it's describing the area here. Region R is rotated through 360 degrees. So this is solid revolution of the solid. So we write pi integral y squared dx. That's how you calculate the volume. Yeah, the exact volume. Okay, so we're going to do that. So we're going to square this. And that's, you square the top, you get 16. You square the bottom, you get x plus 2 squared. But when I bring it up, it's just x plus 2 to the minus 2, right? And then dx. So this one is nice and easy. Because you can use something called the reverse chain rule. So I'm just going to bring 16 pi out because I can do that. And what about the bounds? Well, the bounds is 0 and 8, right? 0 and 8 like that. So when we integrate this kind of thing, we just do like a polynomial, so we can use a power rule. So that would be the power adding by 1 and divided by the added power. And when we differentiate inside, we get 1. We're going to divide by 1, so that doesn't change anything. So that's done. The integral is that. And we put the bound 0 to 8. Okay? So we're going to get 16 pi. And inside here, we put the bounds in. So we get 8. Put the bounds in. We get 8. 10 divided by minus 1 here. So it's 1 over... so this is minus 1 over 10, right? And minus, the same thing, we put 0 in, we get 2 to the minus 1 here, which is 1 over 2, so that's 1 over 2 there. All right, so this is 1 over 2 minus 1 over 10, which is 5 over 10 minus 1 over 10, which is 4 over 10, which is 2 over 5. So this is 32 pi over 5. That's my final answer. Right, let me check that again. So 5 over 10, 4 over 10, 2 over 5, 32 over 5. Yeah, I'm happy with that. So let's go do the next question. Question 2. Question 2. Okay, let's use this area here. So A. So question 2, find the expression of dy by dx in terms of x and y. All right, so this is implicit differentiation. Yeah, so we're going to differentiate each term. Note down that there might be a chain rule. Okay, so differentiating 3x respect to x, we get 3. Yeah, so okay, so I'm just gonna do this. So I'm just gonna write everything. Yeah, might be a bit tedious, but I'm guessing that's good working. So we sort of like apply d by dx for the whole equation. So differentiate the first term, we get 3. Differentiate the second term, which is 5y to the 2. We just do it like as if we differentiate the x. But then we just add dy by dx. Right? So if you take y as if it were x, you would get 10x, right? But it's actually y, so you write y and then you just add dy by dx. That's just a quick way to do implicit differentiation here where you have to use chain rule. The next term, well, this one, we have to use a product rule. So I'm just going to do 4x squared as the u. So u dv differentiating y, I get dy by dx, right? And plus v, which is just the y, I write on the back here. And differentiating the u here, I get 8x, right? So that's just product rule, done. And now we got to be careful differentiating 10 to the 2x, right? Because when you differentiate a to the x, note down that this is not an e, so you get a to the x, but you need to do a ln a. So differentiating 2 to the x here, well, 10 we don't do anything. So we're going to get 2 to the x and then multiply ln 2 as well, just following this rule here. Differentiating 35 will disappear, so that's done for the first working line. And because we need dy by dx, so we gotta accumulate or simplify the dy by dx term. And then we factor dy by dx out, so we're going to get 10y added with 4x squared. So I'm just going to do 4x squared plus 10y here. All right. And then I'll push the rest of the terms to the right-hand side. So I'm just going to do 10 ln 2 times 2 to the x here, which is that term. And then pushing the other terms to the right side. Let me just tidy up a bit because I need more space there. And then this will be, hang on, plus, minus 8xy and then minus 3, right? And then we are going to get, I'm just, tidying up space. We are going to get dy by dx equals all that divided by this, right? I don't think we can simplify anything there, so we're just going to keep it like that. And all that divided by 4x squared plus 10y. And that is done, our dy by dx. In terms of x and y, so that's nice. And next one is b, yeah? Okay, b, find the exact value of the gradient of the tangent to c at p. So what is point p? The curve C cuts the y-axis at point P. So cutting the y-axis means that x equals 0. So when x equals 0, right, what do we have for the y? So if you put all 0 to the x's, we get 0 plus 5y squared plus 0 here equals 2 to the 0 is 1. So that's going to be 10 for the first term on the right side. That's still 35. So here y would be 45 divided by 5, which is 9, and then we got a square root. We could get a plus or minus here, but because y is greater than 0, right? Because I look at the question there, it says on the first line y greater than 0, so I can only take y as 3, which is the positive square root 9. So x equals 0, y is 3 is the point P. We want the gradient then. So dy by dx at y at point P would be just substituting to our first derivative formula here. So 10 ln 2, we want the exact gradient. So that's 2 to the x, which is 0, minus 8 times 0 times y, that's going to be 0, that's fine. We just write everything first. And then 4 0 squared plus 10 times 3. So that's just the substitution. Since we have done that, once we have done that, we can just get the actual answer. So this is going to be 1. That vanishes to 0. So this is 10 ln 2 minus 3. Right? And divided by, that's going to be 0. So that's 30. I think that's exact already. So I don't need to simplify unless we can split it into 2 separate fractions. So if you divide 30 into the first part here, you get 1 over 3 ln 2. If you divide 30 into the second part here, you get 1 over 10. Well, that can be also an exact value. So that's done for question 2. Question 3. All right. A, find the values of the constants A, B, C. So this is basically binomial. And the thing with binomial is that you got to start, you must have, the formula goes like 1 plus something to the power of n. So if the first term is not 1 yet, you got to make it 1. And note that we also have a 6 here. So in order to do that, we pull 4 out, we factor 4 out. Inside here is going to be 1 plus a over 4, right? Because when you multiply 4 back in, you're going to get a. That's fine, it's just checking. And then you got to power this by minus 1 over 2 as given in the question. But don't forget that when you pull 4 out, you got to power by minus 1 over 2 as well. And that is our actual form to be expanded. Well, 4 to the power of minus 1/2 is like 1 over 4 to the power of 1/2. That is 1 over square root 4, which is 1 over 2. So this is 1 over 2. you multiply this 1 over 2 here with 3, with 6, you get 3. So that's 3. And then now we can do the binomial expansion, right? So the formula goes like, you're going to have 1 for the first term. Yeah, so 1, and then plus nx. So n is minus 1 over 2. And then x is a over 4 in this case. Let's find the values of constant a, b, and c. Okay, so we are given that this is the final form. So we're just going to expand up to x to the 2 first. This is, so nx here, that's it. Well, we have an x here as well. Okay, don't forget. There you go. And then plus, well, just the constant minus 1 over 2 times minus 1 over 2 minus 1, so that's minus 3 over 2, yeah? That's the formula. And then you gotta divide that by 2 factorial. And then this will be a over 4x and then squared. So that keeps going. So the next one, if you want to expand to the next one, it will be minus 1 over 2 times minus 3 over 2 times minus 5 over 2, because you keep subtracting by 1, right, for the group here. And then that one would be dividing by 3 factorial, and this would be powered by 3, yeah? Okay, so I'm just going to close the bracket here. Now, the next line is, all right, so we can see here that b is the first term, so b would be 3 already, right? Because I expanded 3 in, I get 3, so b is the first term. And now we can see that the second term is, we're going to get a minus. So this is minus a over 8 multiplied by 3. We get minus 3 over 8 ax, right? So that tells us that minus 3 over 8a here must be equal to this very coefficient, minus 1 over 4. Because they are the same term. And that is telling me that if I solve this equation, I'm going to get a. So a is 2 over 3. Just moving everything to the other side, isolating a. Yeah, I think I'm cool with that. Okay, so a is 2 over 3. And then what about c? Well, c is the other term, is the term x squared here. So we got to do this coefficient with that, and we're going to get the answer there. Just going to move this down first. Okay, so this is plus. So we got a 2 minuses here. That's going to be a plus, of course. So this is 3 over 4, dividing again by 2, we get 3 over 8. 3 over 8 multiply in by 3, we get 9 over 8. 9 over 8 multiply with the square of this, so it's 9 over 8, right? Multiplying again by 1 over 16, a squared, x squared. I'm just, mentally calculating that. So this is unsimplifiable now. So that means we're going to get, for the third term, c will be equal to all this. 9 over 8 times 1 over 16, a squared. Okay, so that's going to be our c, which is 9 over 8 times 1 over 16. A squared is going to be 2 over 3 times 2 over 3. Yeah, because we just got a as 2 over 3. I mean, if we assume that that is right, then that should be our c. Well, we can do some simplification here. 3 and 3 will cancel 9. 2 and 2 will cancel 8 to 2. So that would be 1 over 32, which is c. So those are all my answer. B, A, and C. That's it. That's question A. Part A. Part B, all right, so let's have a look at part B, right? State the range of values of x for which this expansion is valid. Well, the thing with validity of the binomial here is that the x term in the formula, so we have 1 plus x to the n. The modulus of x here must be less than 1, because then otherwise the expansion won't be a convergent series. The value won't be small enough so that it's a good approximation. So that has to be less than 1, so that when you keep expanding, the term with the higher powers of x will vanish to a very small number, right? So that's the reason behind this, yeah? But our x term here is not actually just x. It is actually a over 4x, right? So we're going to do absolute a over 4x less than 1. But what is a? We already know a, which is 2 over 3. So that's 2 over 3 multiplying in here, substitute it in. So we get 1 over 6, right? So that would be 1 over 6x less than 1. Then the range of value for that would be just simplifying this modulus inequality here. So you're going to get 1 over 6 less than 1 greater than minus 1, because you can go either side of the number line, right? So that's probably, not yet. I can multiply 6 across, so I get that instead. Because you just multiply 6 across, you get that. Because we want the range of values for x, right? So yeah, I think that's fine with me. Okay, so question C. For the expansion, find the coefficient of the term x cubed. Well, here we go. We gotta do, so we don't need to write the whole expansion again. We just know that, okay, this is gonna be minus 1 over 2. Okay, just write down minus 1 over 2, minus 3 over 2, and then the other one minus 5 over 2. And then what was it again? A over 4 to x here would be 1 over 6x to the power of 3 now. And this will be all divided by 3 factorial. That's it, because you know what you're getting for the third term. Yeah, so a over 4 in our case here is 1 over 6, because you substitute that into that already. And then you would divide by 3 factorial, you add another term here, minus 5 over 2. But I didn't forget to multiply 3 into it as well. Yeah? Okay, so what is this then? We're going to simplify all this, but I think maybe I'm going to need a calculator. So yeah, let's do that. We're going to get a negative, so I'm just going to do a negative after all this. Maybe I'm not going to do that just yet, because putting a negative sign will take me some time. So I'm not going to do that just yet. So 3 factorial is 3 times 2 times 1, which is that. And that is just 1 over 6 to the power of 3. And then I need a fraction. Yeah. So coefficient. Then it is 5 over 1152. I think I'm happy with that. Oh, minus. I never forget. Okay, because there are 3 minuses here. Let me check everything here again. Yeah, I think I'm happy with that. So that's it. Okay, so that's done for the third question. Let's go to question 4. Okay. So question 4 says the volume of spherical balloon is increasing. So this is rates of change, yeah? It's in differentiation. This topic could be tricky for some people. But I'll give you the technique. Find the rate of increase of the radius of the balloon. So we just know what we find first. This is dr by dt, where r is the radius. So let's think about all the involved parameters. There are v, volume, r, which is what we want to find here, and then always time, because this is about rates of change. It's always time here. And that's it for the first question. Now, it's given underneath the question that volume of a sphere is 4 over 3 pi r cubed. Well, some people already know that, but some people may forget. So this is very kind. Now, we want to find dr by dt. The technique here is to construct a chain rule equation. I already talked about this in the other paper I walked through in P4. You construct a chain rule equation to make this dr by dt. So you dr by the other parameter, which is dv, times dv by dt. Now, as you can see, the dv would cancel, and that would bring you back to dr by dt, but that's not what we want to do here. We want to find dr by dv separately and dv by dt separately and multiply them to get dr by dt. But dr by dv here is kind of like from dv by dr, right? And then we're going to flip after we find dv by dr. So dV by dr is just by differentiating the volume formula there respect to r. So you would get 3 times 4 over 3 pi r squared. I'm just differentiating the formula there. Yeah, this formula right here, respect to r, right? So that is actually a familiar formula. So you differentiate the volume of a sphere, you get a surface area actually. So if you flip that, then dr by dv would be 1 over that, right? We just plug that in. And I guess dv by dt is given. So the instant... Oh yeah, the volume is increasing with the rate of 70 pi. So we're going to plug 70 pi in there. And then because it's already telling you that the radius of the balloon at this instant is 5, so dr by dt is just substituting in all the numbers. So 5 squared there, multiply 70 pi. Pi cancel. So this will give you what? So that's 70 divided by 100, right? I shouldn't have done that. Okay. So that's just 7 over 10. Or 0.7. Yeah, I think I'm happy with that. Just making sure. 0.7, this is the rate of change of radius, so that's cm per second. Yeah, that's done for A. For B, that's not even A, it's I, right? So, hang on, yeah. Okay, for II, the depth of the water in the cave is being monitored. The rate of increase of the depth of water, h centimeter at a particular point in the cave, is modeled by differential equation. Now, a different topic. Okay, we get a differential equation there. Is a constant. Okay, k is a constant and t hours is time after monitoring began. Given that, initially the depth of water is 4. Okay, so they just give you initial conditions, some boundaries, some other conditions to make you solve this differential equation entirely. So this is integration by separation of variable in integration, right? So the first step is to separate the variable. So we move the h cubed to the side of dh, and I'm going to move dt to the side of k, which is a constant. And then we integrate both sides. Just applying the integral sign there. Yeah, so we integrate h cubed with respect to h. We're going to get h to the 4 over 4. All right, that's not bad. We integrate k, which is a constant, with respect to t. We're going to get kt. And don't forget that we should get a constant as well, because we don't know the conditions yet. We didn't put the bounds in. And it says that initially the depth of water is 4. So when t equals 0, h equals 4. We put that in, we get 4 to the power of 4 over 4 equals 0 plus c, right? Okay, so that is just to get the c constant, which is 4 to the 3 here. And that is 64. Okay, 4 to the 3 is 64. So now I update my solution here. H to the 4 equals kt plus 64, right? Okay. There are more conditions to go. So 5 hours after monitoring began, the depth of water is 6. So 5 hour, t equals 5. Let's see if t is hours. Yes. H equals 5 as well. So 5 to the 4 over 4 equals k times 5 plus 64. Do you see that this is just to find k, right? So 5 to the 4, I believe, is 625 over 4 here. Yeah. Minus 64 divided by 5 will give you the value of k, right? Okay, so let's just put that in a calculator, which is full of adds, but that's fine, I guess. Oh, hang on. Oh, no. Okay, so 625 divided by 4, and then I'm just trying to get the calculator to work here. Minus 64 here, divided by 5 again. Okay, I'm gonna make that fraction, maybe this kind of fraction. Okay. Okay, exact fraction. And then t hours after monitoring began, the depth of water was 10. We want to find t. Okay, now we solve the differential equation. Yeah, I think we have. This is just, so k is just that. So the differential equation is h equals, h to the 4 over 4 equals k is just that value there, t plus 64. So now we want to find the value of t when h equals 10, right? So it's 10 to the 4 over 4 equals 369 over 20 times t, because that's the letter they use. And then we're going to solve for this t. So t here to 1 decimal place, so that's fine. I'm just going to rearrange this. Minus 64 and all divided by, maybe I'm going to do a like that. All divided by 369 over 20, like that. Okay, so let's do fraction here. And then another fraction, 10 to the 4 over 4. And then minus 64, or minus 64 divided by 369 over 20. Here we go. So t is just 132.0, 1 decimal place. That's quite a lot of hours. Yep. Well, let's find out if there's anything wrong with this. So depth of 10 centimeters. Yeah, I put 10 to the 4 there. And then over 4. 10 to the 4 over 4. Just checking the result I got here. Oh no, that's a mistake. Yeah, this is 6. Yeah, all right. This is 6. Okay. The depth of the, yeah, all right. Sorry, guys. 6 to the 4, right? But this is fine, I guess. Yeah, it's not 5, it's 4. It's 6. And then k is 5 here. I guess that's right. So minus 64. That's going to take a while now. So 6 to the 4 divided by 4. And then I'm going to minus 64 there divided by 5. Oh, that looks a lot more promising. 52. So this is 52 instead. And then we put the depth of 10 in. That's fine. This is 52. This is then 52 instead. And then we want to find the value of t. All right. So 10 to the 4 divided by 4. Yeah, this calculator is quite hard to use, but I don't have the proper calculator. Somehow I don't. And I'm not going to bother buying one. So you can donate if you want. Okay. So this is instead 46.8. Yeah, that looks more right, at least. Yeah, I guess I'm going to go and do other questions now. All right. Okay, number 5. Well, integrate that, yeah, for I. So let's do that. Writing the answer in simplest form. All right, always do that. Well, from the first glance, the most appropriate method is probably by parts. So we're going to do u equals x squared, because when we differentiate that, it simplifies. So that's why we chose as u. So du by dx is going to be 2x. And then dv by dx, we let it be e to the 4x, because we then want to find v. So v would be, integrating that, we get e to the 4x. And instead of multiplying 4, we would have to divide. That is just reverse chain rule of integration. Yeah. All right. So that integral is then equals to uv x to the 2 times that minus v du. So du is 2x, yeah? And then times v, which is e to the 4x over 4, and then dx here. Okay, so it seems like we need to integrate by parts again. So here we have 2 and 4 cancel to be 2. We are now integrating it again. Okay, so we write down the result here first. Okay, so we open big bracket there. I'm gonna take the 1 over 2 out here, yeah? Because 2 cancel 4, we get 1 over 2. I'm just gonna take it out. It's easier. And then we're gonna do by parts again. So we make u equals x and dv by dx equals e to the 4x again. Yeah, just the same pattern. If you went with that first, then you're gonna keep going with that. Yeah, with that kind of substitution. So again, this is uv, so u is x. dv by dx, to get v, you gotta integrate that. So integrate that, you're gonna get, again, the same thing, e to the 4x over 4, right? Yeah? That's just the v. Let me write it down as well, yeah? Just a little v here is 1 over 4, e to the 4x, and du by dx is gonna be 1. All right. Okay. So again, this is a minus integral. So u will vanish to 1 now, but v is 1 over 4 e to the 4x, right? So we need to still integrate that bit. All right. We got to be really careful with all the sign, guys. Yeah. Okay, so I still keep writing down. So this is still fine, e to the x e to the 4x over 4. Now integrating that, right, is still the same thing because this is exponential. So it's still e to the 4x, but also in extra divided by another 4. So we get 16 there. So that becomes 1 over 16 e to the 4x, yeah? So we expand all the signs. We get x e to the 4x over 4. That is 1 over 2 times 1 over 4. We get 1 over 8 x e to the 4x. Multiplying the 1 over 2 into 1 over 16, we get plus because that's minus and minus, yeah? Plus 1 over 32, and then e to the 4x. It says in the simplest form, so I'm just gonna maybe factor out e to the 4x. How about that? And maybe I'll take 32 outside as well, because then all the things inside will not be a fraction. So here the first one, I get 8x squared, right? Yeah, because if you try multiply that in, you get 1 over 4. And then here, this one is a minus 4x, right? Because when you multiply in, you get 1 over 8. And then the last one is just 1, because when you multiply in, you get exactly 1 over 32 e to the 4x, yeah? So that's it. That's the simplified form for the answer. Next one. Let's see again. Hang on. Yeah, I think I'm happy with that. Okay. Use partial fractions to an algebraic integration to show. Well, let's do partial fraction first, right? So we're going to set that whole thing. Note that this is 2 minus x equals, so I'm going to set a over 2x plus 1 plus b over 2 minus x, eh? Okay. Now, if you multiply by the lowest common multiple, which is this guy, across every term in the equation, you're going to get on the left side just 2x plus 11. And then on the right side here, 2x plus 1 will cancel with that. So a here will be left with just that bracket. And b, similarly, will be with the other bracket, yeah? Like that. So there are mainly 2 ways to do this. You can compare coefficients and work out a and b. But I'm just going to let x be 2 because when we do that, this will vanish, right? So 2 goes to x here. We get 2 times 2 plus 11 equals, this will be 0. And 2 goes into here. We get a 5b, yeah? So that means b is equal to 2 times 2 is 4. 4 plus 11 is 15. 15 over 5 is 3. That's B. And then for the A, we do similar, because we have another critical value here, which is minus 1 over 2. If you substitute into x, B is going to vanish. So x is minus 1 over 2 here. If you substitute minus 1 over 2 into the x here, you get minus 1. Minus 1 plus, I'm just going to write that actually. So this will not be 0 now, it's 2 minus minus 1 over 2, and that will be 0 instead. So minus 1 plus 10, we get 10, plus 11, sorry. And then this one will be 5 over 2, right? You add 2.5 there. So that will be A equals 4. Yeah, that's my 4. Okay, so then we integrate already, yeah? So we integrate 4 and 7. So that whole fraction will be split into partial fractions, which is A over 2x plus 1 plus B, which is 3 over 2 minus x dx, right? So we are getting this. That's it. We are integrating this, guys. Okay. Now, it seems to me like we should do something with the fraction of 3 over 2 minus x there, because when we substitute the bounds in, that the ln might turn into a negative form. So just to be safe, I'm just gonna do minus here, minus, and then swap that x minus 2. It's kind of the same, but yeah, I'm just gonna be safe here. But I mean, when you integrate, you should get a ln of, you should get the modulus sign with a ln function anyway when you integrate partial fraction here. You will know what I mean, yeah? So integrating the first term, we get 4 ln, yeah, absolute 2x plus 1. And then reverse chain rule, we need to divide that by 2. Minus, so you see, ln of x minus 2 here, right? It's kind of the same thing. And then we sub the bounds in 7 and 4. Okay? Right. So you see, if it was 2 minus x like before, then when you sub 7 and 4 in, it would make inside the ln negative. I just don't like that, although I know that there is a modulus sign here. It's just a bit risky. Yeah. So here we have, well, this we can do 2 instead, right? So I'm going to do separate on each term using both bounds. So this is 2 ln. When you have sub 7 in and sub 4 in, the ln will be a division instead. So that will be 2 times 7 plus 1 divided by 4 times 2. It should be 2 times 4, yeah? Plus 1, which is actually the same. And then minus here, ln 7 minus 2 over 4 minus 2. Yeah, just using the log property there, you will end up like this. It's just neater to just simplify it when you substitute the bounds like this. So you get 2 ln, so this is what? 14 plus 1 is 15. 15 up there. And this is 8, yeah? Plus 1 is 9, so 15 over 9. Minus 3 ln, this is 5 up there, and 2 down here. Now we need to simplify to a rational constant, right? Let's see. So, well, I can cancel that. So this is 2 ln 5 over 3. So that's ln 5 over 3 minus 3 ln, that's 5 over 2. Okay, let's see. We can kind of like merge the thing. Yeah, let's merge them. So it's like ln. So if I bring the number in front here up as a power first, I'm going to get 5 over 3 to the 2. And then, so yeah, 2 up here, we get this. But then minus here means that we're going to divide the arguments, where the other one here is doing the same thing. So 5 over 2 to the 3, right? Yeah. And then that would be 5 over to the 2 times, hang on. So this is ln of 5 times 5 divided by 3 times 3. Well, yeah. And then I'm just flipping the fraction, so I get 2 times 2 times 2 divided by 3 times 3 times 3, right? I'm just old-fashioned, so I'm not using a calculator, so I'm canceling 5, and then I get ln, what is that, 8 on top, and this is 49. Yeah, so that's it, I think. 949. Wait, what? 45. 9 times 5 is 45. Yeah. Well, yeah, I guess we could simplify this, but I'm just going to go with that, yeah? That is fully simplified rational constant. I think I'm happy with that. Yeah, because if you want to simplify that by pulling power down, I don't think it's going to... It could get to be a two-term answer here, but I think that's fine by me. I'm going to go with that. All right, so that's my answer. Okay. Next one is number 6, is proof. It's probably the question that most people wouldn't care about in P4, but I do. Because if you know how to do it, it's easy 4 marks. Like, for example, you are required to prove by contradiction that if n squared minus 4n plus 5 is even, then n is odd. Well, we just write the assumption first. That's the key step. We need to get the assumption right. So assumption is that you got to change the pattern of the language here, if and then, to there exist. Okay, there exist. So we got to change the number, a number n, where we got to write the back here first, but we put a negation, which is the opposite meaning of n is odd, where n is even. That is where we put the negation in. Where n is even, such that n squared minus 4n plus 5 is even. We're not changing the first part here, so we only change the second part, okay? So we assume first that n is even, then that whole thing will also be even. Because n is even, now we go have a start on the proof part. So n is even, so we can write n equals to k, where k is an integer, yeah? Okay, so we start with that. And then we're going to do the whole thing. So n squared minus 4n plus 5 is going to be equal to 2k squared minus 4 plus 5. So that's 4k squared minus 8k plus 5. Now, in order to make this clear whether it's even or odd, we got to factor out 2 somehow. So how about I factor like that? I get minus 4k and plus 2 with a plus 1 outside. So we know that when we have a multiple of 2 and then plus 1, this is not an even number. Okay, so I write n squared minus 4n plus 5 is a multiple of 2 but plus 1. So not so an odd number, right? It's an odd number. But we assume at first that it must be an even right here. So this contradicts. Yeah, right? We got to write that. This contradicts the assumption that n squared minus 4n plus 5 is even. Therefore, that's the concluding step. We just write the whole thing. So we just write whatever we want to prove. If n squared minus 4n plus 5 is even, then n is odd. Just a no-brainer step here, really. It's just writing down what we are required to prove. And I'm done with that. I'm just going to go do question 7 now. We had 44, so I think we're fine. Question 7 asks you to integrate that straight using substitution. That's kind if it tells you what to do, I think. So I'm just going to go. So, okay, let's change the bound first. So we're going to change the bounds to a theta, right? So we do 2 root 3 equals 4 sine theta there. Just to find the theta instead. So theta would be, arc sine root 3 over 2 if you just rearrange the equation. Yeah, and that would be what? Root 3 over 2 is, I think it's pi over 3, yeah? It's sine 60. Yeah. And then do similarly, we get 2 equals 4 sine theta. Theta equals arc sine a half. And that is pi over 6. So the lower bound is pi over 6. So then we have integral pi over 6 here and pi over 3 up here. Okay, now substitution, right? So we're going to sub x. We're going to sub 4 sine x into the x here. But let's do dx by d theta first, because we're going to do that anyway, because we're going to change dx to d theta as well. So dx by d theta is 4 cos theta, just differentiating the sign. So that means dx is 4 cos theta d theta. We're going to substitute dx into that. And also the denominator part here is 16. X squared would be 16 sine squared, right? 16 sine squared all to the power of 3 over 2. And then don't forget dx, we're going to change it to 4 cos theta d theta as well. So we are home free now. We just want to find this whole thing in terms of the actual answer, exact value. Okay, so I'm looking at this term. I can pull 16 out. But it must be, a 16 to the power of 3 over 2 as well, right? When you pull it out. Just like the way you would do in binomial when they have a constant inside, you want to pull it out. And then imagine, right? When you pull 16 out, you get 1 minus sine squared. And that's going to be cos squared, right? Trig identity. Still the same power there. And I'm just writing everything here back again. Upper bound, lower bound, we can ignore that for now. That's fine. Then this is to the power of 3 over 2. If you simplify the power here, you can multiply the power together. And that will be cos to the 3. Cos to the 3 here will simplify with cos theta here. So you would get 1 over cos squared down here, right? Okay, just make sure you follow that. And for here, we'll simplify with 16 to the power of 3 over 2. 16 to the power of 3 over 2. So I square root 16 first, I get 4. 4 to the 3 there is 64. And 4 here is that. So simplifying again, I get 1 over 16. I can pull 1 over 16 outside because I don't like keeping it inside. And then I'm going to take back the bounds, which is pi over 3 and pi over 6. And this is d theta. I'm just simplifying everything, guys. All right. Now, how do we integrate that? Well, we know that 1 over cos squared is sec. Yeah? Okay. Keeping 1 over 16 as well. And sec squared, right? How do we integrate that? Well, if you open up the formula booklet, because differentiating tan, you get sec squared. That means integrating sec squared is going to give you tan. Right? That's just as simple as that. Because we know the derivative of tan is sec squared. So you get 1 over 16. I integrated already. I get tan theta here, just that. And then putting the bounds in, I get pi over 6 here and pi over 3. If we now find the value of that, it is just going to be tan of pi over 3. What is tan of pi over 3? That's tan 60. Tan 60 is root 3. Tan of pi over 6 is tan 30, which is 1 over root 3, yeah? I just happen to know them. So if you simplify that, this is going to be, so you multiply root 3 by root 3 over root 3 here on the first term, you get 3 over root 3 minus 1, and then all the same fraction like that. So this will be 2. 2 will cancel with 16. I get 1 over 8 root 3. Or you can make it a nicer fraction. You multiply by root 3 over root 3 again. So you get root 3 over. The bottom bit will become a 3. So that would be 24. That can be the answer, right? Okay, I'm just going to go with that answer right now. I think this paper I'm gonna be in a rush a little bit because I don't have half an hour. Sorry, 1.5 hours. So I'm just gonna maybe take the liberty in doing it quickly here. Okay, A for number 8, it's a vector. Relative to a fixed origin, all the line has equation that, okay, the point A, point B lie on the line L. A has coordinate that, B is coordinate that. Find the value of constant A, which is the y coordinate of point A, and the value of constant B. It says point A and point B lie on the line. So that means we can construct the vector equation of the line by using A and B. Yeah? All right. So I'm guessing we can find AB here, and we call that vector B, which is the one that goes into 4, 2, and minus 1, right? So this is B minus A, yeah? So I'm just doing that. So this is vector AB. And I'm gonna get B plus 2, 3 plus 3 minus A, and 1 minus 4 is minus 3. We can equate that into the 4, 2, minus 1. So I'm just going to make B plus 2 equals 4. So B equals 2. 3 minus A equals 2. I'm equating it to this vector, guys. Yeah, so this vector is going to be equal to this vector because that's the directional vector of the vector equation. So 3 minus A equals 2. That's the middle thing there. So A would be equal to 1. Oh, hang on. Okay, this is not the way it is now. I think we gotta divide that by 3 first to make this actually equal. Right. Okay. Okay. Yeah, all right. I'm thinking that we need to do something with this to tweak it. Because if you look at the bottom part here is minus 3. So I'm gonna do it like this. Okay, I just spot that. So this is, if you pull minus 3 out, yeah, you're gonna get B plus 2 over minus 3. Hang on. So B plus 2 over minus 3. That's the first component. And then 3 minus A over minus 3. And then that will become, hang on, sorry, I just pulled 3 out. Yeah, I pulled 3 out only to make the K component here become a minus 1. Right? Only that. Because then we can say that now B plus 2 over 3 will be equal to 4. All right? Because we need to make it the same as the vector with the lambda there. So lambda somewhat will be a multiple of 3. Because 3 here, we just don't do anything to it. We just equate the directional vector part there to 4, 2, and minus 1. So this will be equal to 4. All right? Sorry, this is over 3, isn't it? Yeah, so B would be equal to 12. Just solve the equation there. No, 10, sorry. Okay. And then we have 3 minus A over 3 must be equal to 2. So that means A is equal to minus 3. Yeah, 6. Yeah, it's 3 minus 6. All right. And then the last part is minus 1, minus 1. All right. So this is our A and B. Okay. So part B now. Find the value of the constant. Okay. Hence find the vector AB. Okay. So AB, we just got it. AB is just this whole thing, right? So AB is just B, which is 10 plus 2, 3 minus minus 3, and minus 3. So that is 12, 6 minus 3. That's my vector AB. All right? Yeah. So we can write it in a component form. So 12i plus 6j minus 3k is the vector AB. All right. And then part C. The point C has coordinates that. Find the size of angle CAB. Well, let's have a line first here, and then A and B are on the line. C is out of the line, I guess. Okay, so CAB, something like that, I guess. So C is 4, 7 minus 2. Okay, so that means we need to find AC and AB first. We already got AB, so we don't need to find AB now. In order to find the angle CAB, which is theta here, we do the vector AB and AC, right? So vector AB and AC here is going to be the thing. Now we already know A, right? A is minus 2, and then the little a is minus 3, so minus 2, minus 3, 4, and B is, we probably don't need B, right? So, okay, so we do vector AB, this is using a dot product. AB dot AC equals modulus AB times modulus AC. I forgot to record my screen on the calculator. And then cos theta. So AB is, we just got AB from the previous question, 12, 6, and minus 3, right? Yeah. Yeah. Dot AC. Well, you got to find AC by yourself. So AC equals C minus A. So that's 6. 7 minus 3 is 10. Minus 2 minus 4 is minus 6. Okay, so 6, 10, minus 6 here. Absolute AB is just the length of vector AB. So we can do square root here. 12 squared plus 6 squared plus minus 3 squared. Multiply with another absolute, AC. So that's going to be 6 squared plus 10 squared plus minus 6 squared. I'm going to move everything. If there's anything I cheat here, it's just the tool I use in this app. Okay, cos theta. All right. So cos theta, I'm just going to do the calculator there, all the work there. Okay. Now, but I might need to do the dot product myself. So 12 times 6 plus 60. Yeah, plus 18. Just the dot product of those two vectors. This will be divided by all the two absolutes there. 12 squared plus 6 squared plus 3 squared. Minus 3 squared and 3 squared are the same thing. Multiply, square root again. 6 squared plus 10 squared plus another 6 squared. There you go. So that is the cos theta. I'm just going to write this step first. Dot, dot, dot. So theta here, we want the size in 1 decimal place in degrees. So I'm in radian right now. I need to do a degree there. And then we put that to answer first. We clear the calculator. We do arc cos answer. And that is going to be the degree in 1 decimal place. All right. Well, let's just do it properly. Arc cos 0.83 blah, blah, blah. So I get 33.7 there in 1 decimal place. Okay, and that's the answer. Question D. Find the coordinates of two possible positions of D. So the point D lies on the line L, so that the area of triangle CAD is twice the area of triangle CAB. Okay, so the point D lies on the line L, so that the area of CAD, so CAD somewhere, is twice the area of triangle CAB. Okay, so D should be, yeah, I'm thinking D should be outside A and B like this. So we have CAD here, D is up here, presumably. And then that's going to be twice the area of CAB, which is this little guy. Now, guys, you gotta have some knowledge about the triangles, right? So let's say I shrink B down to that. D is here. So this is C. So I'm going to draw the triangle out so that you can see. CAD would be my green one. Okay, let's say that that is a proper triangle. And then CAB, let's say in purple. Sorry about the not nice drawing there. Now look, if we say that CAD is twice, the green one is twice the purple one, it means that the distance AB should be twice the distance AD because they have the same height here. If we assume that this is the height of the triangle, yeah, the perpendicular distance from the line to C, they both have the same height. And that means if the base of AB is half that of AD, then the area would be also half. So we can say that AB is just half of AD. Just like that. Or at least the magnitude. So we can do the magnitude here. Alright? Or we can just do the vector. Actually, we should do the vector. So they are parallel and AB is just half of AD to make it half the area. Right. But we already know AB, that's good. So AB, where's AB? Our AB is 12, 6, and minus 3 here. So 12, 6, and minus 3. It's going to be equal to half. Well, AD we don't know yet, but AD is D minus A. So AD is D, which is... What is point D? D lies on L. Alright, so D also lies on L, so we got to use the vector equation. The vector equation of L is again the same thing, 2 minus 1, 3, and lambda for 2 minus 1. Yeah, this is where we finally use the vector equation. So that's going to be 2 plus 4 lambda. Wait, this is point D, yeah? Or D. So that's the vector equation of point D, which is just the equation of the line, basically. Because that's what it's there for. Okay, so then AD would be equal to OD minus OA. Yeah, so this is AD. OD minus OA, so we get that thing minus A. Let me write down A first here. A is minus 2. A, what is value of A? I think A is minus 3 here, okay. Minus 2, minus 3, 4. So AD is D minus A, so it's 2 plus 4 lambda minus 2 is plus 2. And then the J component, minus 1 plus 2 lambda minus 3 is plus 3. And then the K component is 3 minus lambda minus 4, which simplifies to 4 plus 4 lambda, 2 plus 2 lambda. Interesting. And then minus 1 minus lambda here. Interesting. So then we can do this. We can finish this. So we just plug AD in there. Yeah, we get 4 plus 4 lambda here, 2 plus 2 lambda there, minus 1 minus lambda there. That means we can find lambda. And then we can plug it back into the point D. Okay. The other possibility is that this has a negative sign because it can go either way, right? So D can be around here, right? So D can also be here. So I'm just going to say plus or minus there, right? Oops. Okay, so this is plus or minus, yeah? Okay, so if you try substitute this in, let's use 1 over 2 as a positive number first. You substitute this in, you get, what do you get? Sorry, no. So you would get 12 equals 1 over 2 times 4 plus 4 lambda. So that means lambda equals, if you solve it, you get 2 plus 2 lambda, you get lambda of 5. I'm just going to check if I get the same thing for the other part. So 1 over 2 subbing in, well, we should just check that, right? Yeah, we get the same thing. So that's valid. Yeah, I think that's valid. So just check the third one. Minus 6, minus 5. Yeah, so that's all valid. So lambda equals 5. And then we're just going to do a minus. So also 12 equals 1 over 2 minus 1 over 2, 4 plus 4 lambda here. So what lambda do you get? So you multiply 2 here, you get minus 24. Oh, wait, hang on. I can do just 12 equals minus 2 lambda, right? I can do that. That's probably easier. So minus 2 plus on both sides, we get 14, and that would be minus 7. And that should be the same for all. So we're going to answer here. Wait. So we get 2 value of lambda. So lambda equals 5 or minus 7. That means the position vector of D would be this guy, 2. So OD is 2 plus 4 lambda, 2 plus 4, 5. And then the other one is minus 1 plus 2 lambda, which is 5 in the first case. And then the last one is 3 minus lambda, which is 5. See if I got that right. Hang on. Minus 1, 2 lambda, 3. Okay. So that's the first case. So 2 plus 20 is 22. That's 9, and that is minus 2. Or minus 7 substituting in now. So 2 minus 4 times 2 plus 4 times minus 7. Minus 1 plus 2 times minus 7. And 3. This is 3 minus lambda. So 3 minus 7. Gotta be careful with that. So this is 30. Minus 14, minus 1, minus 15. And that is 10. So D is 22, 9 minus 2, or 30 minus 15, 10. That's my answer. All right, that was a heck of a question there. Vector, tricky. Okay, question 9 now. Bye question 8, question 9, this whole lot. Let's see. Okay, so question 9, I'm going to start writing from here. Okay, 9a. Okay, we get the parametric equation right here, right? Use parametric differentiation to show that dy by dx equals k sine t. Okay, so parametric differentiation, we do dy by dt equals, that is 3 bringing down, we differentiating the y there, respect to t. We use a chain rule. So the power subtracted by 1, we get sine squared, and then we do a chain rule. Differentiating the sine t, we get a cos t. Okay. And dx by dt is going to be equal to, well, differentiating cos, we get a minus sign, right? A minus sign, and then sine 2t, and then we bring the 2 out already here because we use a chain rule to differentiate the angle as well. Okay, so that's what I got. And then dy by dx is then just dividing both of them. So we do 3 sine squared t cos t first, and then divided by that. So that's minus 4 sine 2t. All right. Now sine 2t is just, so let me do this already. Yeah. Sine 2t is 2 sine t cos t. So that's going to be minus 8 sine t cos t, right? So I'm just going to change that to minus 8 sine t cos t, yeah? Just using a double angle. All right, so this is 8, and yeah, I think that's right. Okay, so cos cancel, sine cancel once, so we get minus 3 over 8 sine t as required. So k is minus 3 over 8, yeah? Okay, so the second part of that, this is the first part, the second part. An equation for L is that. So we have a line L as well here in the diagram, as you can see. There you go. An equation L is that. So L is a tangent to curve C at P. But point P is where t equals pi over 6, right? So when t equals pi over 6, we got to find the x value so that we... Oh, no, we don't. So we can substitute that into the dy by dx already. So that's minus 3 over 8 sine pi over 6, right? Sine pi over 6 happens to be 1 over 2. So that is minus 3 over 16. Yeah? But we got to find the x and the y coordinates anyway, I guess. So x at t equals pi over 6 is 2 cos 2 times pi over 6, right? I'm just substituting in the angle there. So 2 times pi over 6 as the angle is pi over 3. Cos pi over 3 is 1 over 2. So that is 1. What about the y? Sine cubed of the angle pi over 6. Well, sine pi over 6 is 1 over 2, right? And 1 over 2 cubed is 1 over 8. Aha. So that's fine. So now we can form a linear equation. So equation of tangent L. Yeah. So y minus y1, which is 1 over 8, equals m, which is minus 3 over 16, times x minus x1. That's the formula for the linear equation. I'm going to multiply across by 16, right? Yeah, because we want everything to be integer. So that's 16y. Voila. We see 16y in the equation there. Minus 2 here. Minus 3x. Because 16 will vanish here. And then minus 3x times minus 1, we get plus 3. We move everything on the same side. 3x plus 16y. That will be a minus 5. And that's as required. Question B down here. The line L intersects the curve again at point P. Okay, so we're going to take the linear equation here and substitute it by the value of x and y as parametric equation. So x here is what? 2 cos t, right? So we take the tangent equation, we substitute the x as 2 cos 2t. We substitute the y as sine cube t, right? And then minus 5 equals 0. So when we solve this equation, we're going to get the values of t when the two lines intersect. All of them, including the point we know already. So this is 6 cos 2t plus 16 sine cube t minus 5 equals 0. Well, by the looks of this, I think we should solve this by using cubic form. And I'm going to be in trouble because I don't have a calculator for that. But I can use Desmos, I guess. So this is going to be 1 minus 2 sine squared t. Yeah. Plus 16 sine cube t minus 5. So this is, I'm going to rearrange the form here. 16 sine cube t. And then minus 12 sine squared t. And then this is 6, right? Yeah. So this is 6 minus 5. I get 1 equals 0. Let me check that again. I think I'm happy with that. And now I'm going to use Desmos to solve that, right? If you don't mind. So I'm going to let sine t be something, solve the cubic equation, yeah? So let's use Desmos first. Okay, so assuming you're going to have to plug in a calculator, a cubic equation, but I'm using Desmos here, so the way I would do it is just y equals 16x where's cubed. Okay, hang on. To the power. How do I do a power here? I think I gotta use the keyboard. Sorry, guys, because I just don't have the calculator right now. That's bad. Okay, to the power of 3, if you don't mind. All right. Ah, this is bad. All right, hang on. Okay. To the power of 3, and then minus 12x to the power of 2, and then plus 1. Whoop. Plus 1. And then let's put that to 0, right? Because we're solving it to 0. So there you go. Oops. Okay. no, let's just do that, and then y equals 0. Okay, so these will be the answer for me. Let's zoom into that. So there are just 2 points, 0 and, okay, so there are 2 answers here. So t equals, we're just gonna take the x value, sorry, so I'm gonna get sine t instead equals minus 1 over 4, and sine t equals 0.5. It's just the x value basically. Yeah, all right. Now back to the calculator, we need to solve for these two. Note that t has the range from minus 90 to 90 degrees. So this is 1 over 2. So I'm going to get the t for this first. So this t is going to be pi over 6. We already got that. So this is not our guys. But what about minus 1 over 4 there? So it's not going to be in the first quadrant, because first quadrant you can't get sine to be negative. So I'm suspecting that we should get radian first, and then arcsine minus 1 over 4. So that is the guy. So t is, wait, exact coordinates? Oh no, exact coordinates. Of point Q. All right. We're going to keep this sine t. We're not going to solve it. That's fine, because it wants coordinates of point Q. So we are good with that. No problem. We're going to keep around sine t is minus 1 over 4. And the coordinates of Q would have to be x equals 2 of minus 1 brackets 1 minus. So I'm just substituting. I'm going to use this sine t to find x and y, right? Instead of finding t first, I'm going to use the whole sine t. Because sine t, if you get the angle, you won't get exact value, right? I'm just going to do that. So this is 1 over 4 squared is 1 over 16 times 2 is 1 over 8. 1 minus 1 over 8 is 7 over 8. So that's 7 over 4 for x. And then, yeah, I think that's fine, because it doesn't matter. And then sine cubed of, yeah, so this is minus 1 over 4 cubed. So you get minus 1 over 64. Let's check if q is kind of in the right quadrant. So x is positive and y is negative. That's reasonable. So that's like in around this quadrant right here, yeah? So q is going to be 7 over 4 and minus 1 over 64. That's the answer there. I think I'm almost out of time, and oh, I'm done. So I'm gonna have to stop here, although I have more time because I need to go now. I have something else to do. But yeah, I'll mark this paper, right? Okay. Okay, so this is the mark scheme for IAL P4 2025 January. Let's get started on marking it. All right, number 1 here, and this is my paper. I did this without having seen it. So the first one, right? Yeah, all the working should be fine. Number 2, I got, what did I get here? All right, so they say find the expression, and this is the final expression. Yeah, 10 ln 2 to the x minus 8xy minus 3. Yeah, this is all fine. Okay, so B, I got 10 ln 2 minus 3 over 30. And then I simplified it to be that. So I guess, yeah, they allow this right here. So I got the mark. Okay, 3. Right, binomial expansion here. A is 2/3. C is 1 over 32. All right. B, right? B, yeah. That's the range. Okay, and then there's this. All right. Number 4. dr by dt is 0.7 right here. And then I, that's a long one. Okay, I got, whoa, okay, so something a little different. Yeah, 46.8. Award 46.8. Yeah, I got 46.8, so I'm fine there. Number 5. This is by parts integration. So let's look at the final form. X squared e to the 4x over 4 minus 1 over 8 x e to the 4x over, okay, 1 over 32 e to the 4x. Wait, I forgot a plus c. How could I? I didn't put a plus c here. Okay, I gotta check if they allow. With or without the constant of integration. Phew. It's fine. So you gotta be careful because some years they don't. But usually, recently, I see that they always allow or condone without the plus c. So I'm fine here, luckily. This one is ln 8 over 45. So yeah, I got it. Okay. Number 6. Yeah, so this is proof by contradiction. So assumption n squared even is even and n is even. Yeah, that's fine. Just different way of writing it. So I tried n equals 2k, attempt this, and then I got this. And then I showed that this is a multiple of 2 plus 1. So yeah, everything is fine. Yeah, that wasn't a hard proof question, so that was fine. This one, 1610, yeah. And then I sub in the bounds, I got root 3 over 24. That was quite fine. Vectors. Okay. See if I nailed vectors this time, because I usually don't. Okay. B equals 10. Wait, what? A equals minus 3. All right, yeah. Here we go. So A and B, done. B, 12, 6 minus 3k. Nailed it. C, yep, the angle, nailed it. And D, so what's D? D is asking to find the coordinates of 2 possible points for D. So if I look towards the bottom, 22, 9 minus 2. Whoa, that is not right. I got this one wrong. Wait. Oh no. Oh, you see this silly mistake. Minus 28 plus 2 should have been minus 26. So the last mark was wrong. So I got minus 1 here. Sorry, guys. Silly mistakes. Okay, but the working was all fine, right? You can follow my working. Okay, so this one, 9 dy by dx is minus 3 over 8 sine t. And then the linear equation as required here. Part B, looking down, 7 over 4 minus 1 over 64 there. So that was fine. Is there anything else? That's it. So I lost 1 mark. Just the one here, a silly mistake. It is hard to even me. Although I've taken the papers myself back like 10 plus years ago. That dates me. Also, I've been teaching this for some years. It's still hard to avoid silly mistakes, but if you don't try, it's going to be worse, right? So I think I lost 1 mark. Yeah, so 74 out of 75. Let's see the UMS calculator, just to make sure. So that's the UMS page, the Pearson qualifications.pearson.com. I'm going to change that to P4 and 74. Ooh, not 100% this time. So that meant that the only people who got 100% UMS were the people who got 75 marks every mark. I missed 1, so I got 99. All right, I got 99 for this one, right? Okay. Now let's do some feedback. Yeah. So I think this one is fine, solid of revolution. This one is implicit differentiation, so just be careful with the long term everything. This one, yeah, binomial expansion. There's no particular point here that I need to stress. Yeah, this one is the rates of change. So again, I think I have said it in the walkthrough that you need to come up with the chain rule equation and find all the things that you need to put in this equation to find what you want, which is dr by dt in this case, right? For this one. And this one, they ask you to do separation of variable to find the equation of h, and actually to find the time for the particular h here. So that was fine. Yeah, this is by parts integration and later on partial fraction integration. Don't forget the c, you never know. You might lose. I would have lost mark here if they didn't allow that in the mark scheme, right? But they did, so I'm fine. Okay, here, yeah, partial fraction. Okay, yeah, I got the ln there. Right. Now you see, I swap this later on into this because I know that if I put the bounds, you know what? Let's do something, right? So if I didn't do this, I got plus 3 over x. Sorry, 2 minus x, and then this would have been a plus 2 minus x. What's gonna happen? Yeah. See if we get the same answer. So this one would have been the same, but this one would have been plus 3 ln. So that's 5 over 2. You see what happens here? This would have been a plus, not a minus, because I intentionally changed this to a minus to avoid a 2 minus x here at first. If you remember in the walkthrough, I said that. Because if you consider the bounds, the 2 minus x would have made the argument of the ln being negative. We want to avoid that if we can. But although let's say I didn't do that and I try put everything like it was. So it was at first plus and 2 minus x here. So it would have been plus 3 ln 2 minus x. And if you try put in the bounds, right? So this would have been 2 minus 7, yeah, instead of 7 minus 2. And it would have been ln 5. You put the absolute sign, fine, but it would have been ln 5 over 2 as well. But the sign here would have been completely wrong. You see the problem there, right? So the bottom line here is that you got to be careful when you integrate something that would give the integral of a ln function. You want to try avoid whatever the integral that you get, you avoid the negative argument inside the ln. So if you see firsthand that this should be the other way around, then you make it the other way around, flip the sign or something, right? Although, yeah, they have an absolute sign, but, you want to avoid that at your best, right? So there you go. I'm just going to undo all that because I might need to publish this later on for you guys. Okay, yeah, here we go. So the proof was fine. So again, this is the key. This was also in P3. If you did P3 as well, then you would see very similar thing here. Proving it's not even or odd or not a multiple of something. That's always the trick. You factorize 2 out of some integer in the brackets here, and then you have a plus remainder. So for the multiple of 2, you can have plus 1. For the multiple of 5, you can have plus 1 to plus 2, plus 3, plus 4. And when they have a plus something, okay, it's not a multiple. It's a multiple of that plus something. So this is to prove it's not a multiple of 2. It's an odd number. Yeah, something like that. Yeah, and this is substitution. It was quite long, but yeah, maybe I write big here. And that was fine. Vectors, yeah. Didn't get me this time, so I'm quite fine with that. Oh, what got me at in the last part is the silly mistake there. All right, and this is another parametric equation, so nothing tricky in particular here. Just do it straight. So that was it, guys. I hope that was useful. I'll see you in the next one.